We continue reviewing statistics. Construct 99% confidence interval for the population mean. And in this sample, we have the group of 19 that has the statistic of the mean and standard deviation of 3.8. Right. So usually the problem with the confidence interval, I just use a calculator. So it's that, go to test, and this is the one that have to do with the population mean. Just go to t interval. And this time we are given the sample with statistic. The mean is 22.4, standard deviation 19. I'm sorry, 3.8. The 19 is n. And 99% confidence interval. Right. So we do that and we just calculate. So if 19.891 and 24.909. So will be, of course, this one. Yeah. So like I said, for this one we just used the calculator. For the population mean, we will use the t interval. And for the t interval, we can use the data if we are given the data like this, or we use a stat if we are given the information of the sample. Right, so pretty much that. Right, next, a local bank needs information concerning the savings account. So the sample of 15, so that is n. The mean 686.75 and standard deviation and 98% confidence interval. Right, so once again we are given the information of the sample, so that will be use stat here. 686.75, standard deviation 256.2, and n equal to 15, and we want 98% confident interval. Right, and do that, we will have 513.14 and 860.36. Right. So very simple. So once again, if we want the confidence interval for the population mean, then that would be the t interval. Right. Next, the grade point average of 10. So we have 10. We are given here, find 98% confidence interval. So in this problem, we are not given the information of the sample. We are given the raw data. So if we use stat and t interval, we should choose data. But before that, we have to enter this number into a list so we can use it. So stat, edit, I'll enter those number 2, 3.2. One point eight, 2.9, 0.9, 4, 3.3, 2.9, 3.6, and 0.8. Right. Right. So we go to stat, test, and option number 8 for t-interval. Choose data from list 1 and frequency list to just one. Confidence interval, this one we want 98% confident. And let's just calculate. So we use t-interval for data. And we have 1.5499 and look like this one. Right, next. A doctor at the local hospital is interested in estimate the birth weight of infants. How large the sample size must be? So we want 90% confident and within 2 ounces. So this is the margin of error is 2 and the standard deviation is 7. So the sample size is equal to the z times s divided by e square. So the z alpha over 2 is whatever corresponding to the 90% confident. So in this case we use the inverse normal to find the z values. So 90% confident with 90 in the middle. And this, if 90 in the middle, 10% on the tails, and then will be 5% on the left tail here. So 5% and 90%, so that's 95%. So if we want, that will be inverse normal. Of 95%. Standard normal. So 0 is the mean and standard deviation is 1. Right? Sorry, second variable. Inverse normal. The area is 195. So you have 1.645. Times 7 divided by 2 square. So we just have this. Divided by 2 square. So we have 33.14. So we can round to 34 if we want to. So n is about 34. Yeah. So z is 1.645. Right, so that's what we have. Right. The next two problems, we'll just write out the hypothesis for the problem. So the null hypothesis and alternative hypothesis. So first one we talk about, we have to read the problem for sure. The mean was less than 100. So we just write like that. And then we write the complement. The complement to this, if it's not less than, it will be greater than or equal to. Now, this one has the equal sign, so that will be the null hypothesis. And the alternative hypothesis is the other one. Now, usually for the null hypothesis is the statement of the status quo. So instead of write less greater than equal to, just write equal to. So that's what we have. Right. So we start with the statement in the problem and then write a complement. Whatever expression has the equal sign, that will be the null hypothesis. The alternative hypothesis will be the other one. Right. Next, the mean is more than 3.6. So the complement to that, if it's not greater than, it has to be less than or equal to. Now the equal to, we go with the null hypothesis. We just want to write equal to. And the alternative hypothesis is whatever it doesn't have the equal sign. Right, so pretty much just like that. Right. So the deriving the hypothesis is the first step. The second step is we do the hypothesis test and write the decision from that. Right. Now we have a few problems here. 50% of registered voters in a congressional district are registered Democrats. The Republican candidate take a poll to see how he's going to do. So we polled 12,000 potential voters, and then 621 vote for Democratic candidate. The Republican have a chance to win. Use alpha of 0.05. So for a chance to win, he has to have. So assume that if when it's equal, then go to a runoff and then all things. So we said if the population is actually greater than equal to 50%, then he will win, right? Now, a little bit tricky here because that 621 go with Democratic. So that means with respect to that, his candidate, his opponent have to be less than 50% for him to win. Right? Once again, this P is the probability of his opponent, not himself, because everything is based on the Democratic side here with respect to the Democratic candidate. Right. So once again, if the Democratic gets less than 50%, and then in the two candidate race, he would win because he would be more than 50%. Right. So the complement is greater than equal to 50%. So in that case, we have to choose one to be the alternative hypothesis and the other one equal to is the null hypothesis. So the first step is the hypothesis. The null hypothesis will be equal to, and the alternative will be less than 2. Next, we use alpha of 0.02. Alpha 0.05, sorry. And then based on this information, we'll compute the p-values. So in this case, x is 621 and n is 1200. Based on that, we can find the p-values. Alright, test that, go to test, and this we have the proportion one proportion z test. Right, we have the the alternating hypothesis is less than. So first we're going to choose proportion is less than. And it's going to be less than 50%. So just 0.5. X is 621 and we have 1200. Right? And I will just calculate. I'll show the p-values. Right. So the p-values is 0.887. Right. And so p-values is bigger than, so we do not reject. The null hypothesis. Right. So that means we're going to go with this. And we're not going with this. And this is when he has a chance to win is where the opponent have less than 50%. And since so we go with this, we say that that candidate, the Republican candidate, has no chance, because we do not reject this. If we reject this, we go with the H1. In that case, he has a chance to win. But in this case, because we do not reject the null hypothesis, the alternative hypothesis, we're not going with that. So that means if he will not have less than 50%. I said the 50% here is whatever the Democratic candidate gets. So he get more than, he's not getting less than 50%, so the Republican candidate have no chance. So the question is, does the Republican candidate have a chance? The answer will be no, because based on that, based on this example, it could not be the case, because once again, we do not reject this, so we cannot go with the alternative hypothesis. So the question would be no. The answer should be no. Right, next. The engineering school at the major university claim that 20% of its graduate are women. In the graduate of that were female. Does this suggest the school is believable? Right. So the university claimed that 20% of the graduate are women. So we said P is equal to 20%. And the complement to that is not equal to. So whatever that has the equal sign will be the null hypothesis. The other one is alternative hypothesis. So not equal to, in this case we have a two-tailed problem. Now 2 alpha 0.05 pre-standard. Number 3, we'll find the p-values. So in this particular we have x equal to 58 and n is equal to 210. Right, so we have everything. So just go to one proportion z-test. So it's, first of all, it's not going to be not equal to, and that particular value says 0.2. So proportion p is not equal to 0.2. So that's good. X is 58 and is 210, and we just calculate. And alpha, the p is very small. And number 4, because p values is less than alpha 0.05, so when p is low, then HO must go, so reject. So we rejected that. So that means this suggest that the score is believable. So we reject that. So that means it's not. So we say there is enough evidence to support that the proportion is not 20%. Yeah, so we go with the null hypothesis. And sorry, we reject the null hypothesis, so we go with the alternate hypothesis. Right. Timestamp. Right, next, an airline claims that the no-show rate for passenger is less than 50%. So the rate is less than 50%, less than 5%. So the complement will be greater than or equal to. So we write the hypothesis. The null hypothesis will be equal to. Instead of greater than or equal to, we just write equal to. And the alternative will be less than that. And then on this problem, we use alpha 0.01. Number 3, we find the p-values. This particular, the sample 420 and 19 no-show. Right, so just calculate once again. For population proportion, we use one proportion z-test, option number 5 here. Alright, first, the alternate hypothesis, proportion is less than, so we're going to choose less than. And then 5%. X is 19. N is 420. And then we calculate. Right, in that case we have P is 0.3. And this is bigger than alpha, so we do not reject. So if we do not reject, we say there is not enough to support that is less than. There is not enough. If do not reject, then we say not enough evidence to support this. To support the claim that it's less than 5%. To support that mean is less, proportion is less than 5%. So we do not have enough evidence to support P1, H1, sorry. Right, so that was hypothesis testing for the population proportion. What we have here is hypothesis test for the population mean. For the population mean, just like what we have earlier with the interval, with the confidence interval, we might given a data or we given a statistic of sample, but overall still the step will be the same. Now let's look at the problem. Manufacturer claims that the mean lifetime, so the mean is 1300 hours. A homeowner select 25 of those. By the way, so that is N, and the lifetime to be 1280 and the standard deviation of 80. Test the manufacturer claim. Route the answer to the nearest 1000. Now this is a little bit tricky. Depends on how we want to set up the problem. When we set, if the company claims that the lifetime, the mean lifetime is 1300 hours, if it turned out to be 1500 hours, that means good. I mean, that's still good, because from the consumer perspective, that claim is still very valid. It's not valid if it is less than that, right? So when we make a claim, if it turned out to be even better than the actual claim, nobody gonna say anything. That's still good. So we only make, if we make a promise or we make a claim that it is come up short to that, then that will be a problem. If it is more than that, if we over deliver, that is okay, right? So in that case, even though we said the mean originally is equal to 1300, but the only problem is where it is less than 1300. That's where we have a problem with. If the company over deliver, that's even better. So we should not worry about that. So in that case, this is a one tail. So we only have to worry about when it's less than 1300, then that is a problem. If it is equal to, it's good. If it is better than, even better. But we really worry about if it is less than 1300. Of course, this is less than, so it will be on the right tail. I'm sorry, the left tail. Right, 2. Alpha equal to 0.05. And number 3, we find the p-values. So this in this sample we have n is equal to 25, the mean 1280, and the standard deviation 80. So based on this information, we can calculate the p-values. This, however, is going to be a t-test. And we use statistic, right? Because n is only 25. So first of all, the alternative hypothesis is less than. So we go with less than. So highlight that. And less than 1300. The mean 1280. S is 80. N is 25. And then we will calculate the p-value is 0.11. I said on all of our problem, we use the p-values. And for, because p-values is bigger than alpha, so we do not reject. The null hypothesis. So that means there is not enough evidence to support H1. That means the claim is good. There is not enough evidence to support otherwise. Not evident to say that the mean is less than 1300. Right? So we try to find the evidence to support this, but it's not enough because we do not reject H not. So that means this is still good. Right, next. A local group claims that the police issue at least 56 parking tickets a day in the area. To prove the point, they randomly select 2 weeks. The research yields the number of tickets issued on each day. The data are listed below. At 0.8 alpha equal to 0.01, test the group claim. Right, now the idea of this, it's just like have to think a little. If we said, by the way, this one is clear. Actually, at least 56. The mean is at least 56. That means the complement to that. If it's not, at least 56 means equal or more, right? So that means the complement will be less than 56. Right. At least meaning greater than or equal to 56 and that. And of course, when we have that, we know which one is the null hypothesis, which one is the alternative hypothesis. I forgot the timestamp. So the null hypothesis, we just write equal to. Right. And then 2 alpha 0.01. Test the group claim 3 to find the p-values. Right. In this case, we are not given the statistic of the sample. We are given the whole data, the raw data here. So we have to enter this in the list, and then we still use the same t-test. Right. First, stat, put in the list first, clear it, and then enter the number. Right. 70, 48, 41, 68, 69, 55, 70, 57, 60, 83, 32, 60, 72, and 58. Right. 70, 48, 41, 68, 69, 55, 70, 57, 60, 83, 32, 60, 72, and 58. Alright, that's good. Now we just do the t-test. Alright, now we use data from this one. Alright, now first the test is less than 56, so we're going to choose less than, and then the number will be 56. List 1. Alright, so pretty much that. Yeah, we enter everything in list 1 and let it calculate the statistic. Now we calculate, focus on the p-values. Right, so p-values 0.869, and it is greater than alpha, so we do not reject it. So do not reject this. So that means, oh sorry, this is do not reject on the step number 4. So that means there is not enough evidence to support this, to support that it's less than. So not enough evidence to say that to support that. It is less than. Yeah. Right. Right. Next, a local retailer claims that mean wait time is less than 5 minutes. Right. So this is the claim, less than 5 minutes. So the complement is greater than equal to 5. So this is the one with the equal sign. Is equal to. And the alternative will be less than. Right? So we only write the null hypothesis with the equal sign. Now alpha is 0.01. And now we calculate the p-values. Based on the information here that sample of 20 has the mean of 3.4 and a standard deviation of 2.1. Right, so we calculate the p-values and then determine what we have from there. For population mean, that is the t-test. This time we have the statistic. Right, first let's look at the hypothesis. This is less than, so still less than. So less than 5, the mean 3.4, standard deviation 2.1, and is 20. Oh, sorry, less than. So we go to calculate, and we have p as 0.001. which is less than alpha. So when P is low, HO must go. So we reject the null hypothesis. So that means it is enough evidence to support the alternative hypothesis. So when we reject that, we said there is enough evidence to support the claim that is less than 5 minutes to support the claim that mu is less than 5. Right. So with that, we cover all the material that I want to review for statistics. I hope you find these videos helpful. Thank you for watching.